Hello everyone, welcome to this video. We are group S-1. I am Shravani Tambe and rest of my group members are Rohan Tambe, Shubham Tambe, Ayan Tamboli, Nauman Tamboli and Prashit Tamane, and today we will be discussing a bit about RISC and CISC processor. So let's start with it.
RISC Reduced Instruction Set Computer. RISC Reduced Instruction Set Computer Processor. The main idea behind this is to make hardware simpler by using an instruction set composed of a few basic steps for loading, evaluating, and storing operations. Just like a load command will load data, a store command will store the data. It is built to minimize the instruction execution time by optimizing and limiting each number of instruction. Instruction cycle requires only one clock cycle and each cycle contains three parameters, that is fetch, decode and execute. RISC chips require several transistors, making it cheaper to design and reduce the execution time for instruction.
In RISC architecture, there are hardwired control unit, data path, instruction cache, data cache, and main memory. The hardwired control unit is the logical unit of this architecture. It sends a signal to the data path. The data path then sends the data values, stores the data values in the data cache and the instruction values in instruction cache. Both the values from instruction cache and data cache are then stored in the main memory.
Characteristics of CISC. First, complex instructions, hence complex instruction decoding. Second, instructions are larger than one word size. Third, instructions may take more than a single clock cycle to get executed. Fourth, less number of general purpose registers as operations get performed in memory itself. Fifth, complex addressing modes. Sixth, more data types.
In the CISC architecture, we have a control unit, an instruction and data path, a cache, and a microprogram control memory. The control unit sends the logical instructions to the instruction and data path, which stores the values in cache and which are directly stored into the main memory.
CISC Complex Instruction Set Architecture. The main idea is that a single instruction will do all loading, evaluating, and storing operation just like multiplication. Command will do stuff like loading data, evaluating, and storing it, hence it's complex. CISC approaches reducing the number of instructions on each program and ignoring the number of cycles per instruction. It emphasizes to build complex instruction directly in the hardware because hardware is always faster than software. CISC chips are relatively slower as compared to RISC chips. Example VAX, AMD, Intel x86 and the System/360.
Characteristics of RISC. First one, simpler instruction, hence simple instruction decoding. Second one, instruction comes under size of one word. Third one, instruction takes a single clock cycle to get executed. Fourth one, more general purpose registers. Fifth one, simple addressing modes. Sixth one, fewer data types. Seventh one, a pipeline can be achieved. Eighth one, fixed length instruction format.
Difference between RISC and CISC. A RISC processor emphasizes on software to optimize the instruction set, but a CISC processor emphasizes on hardware to optimize the instruction set. A RISC processor requires multiple register sets to store the instruction. CISC processor requires a single register to store the instruction. A RISC has a simple decoding of instruction and uses of the pipeline are simple in RISC. In CISC, the uses of pipeline are difficult and it has a complex decoding of instruction. It uses a limited number of instructions that requires less time to execute the instructions. But in CISC processor, large number of instructions that require more time to execute the instructions. The examples of RISC are ARM, PARISC, Power Architecture Alpha, AVR, ARC, and SPARC. Examples of CISC are VX, Motorola 6 8000 family, System 360, AMD, and Intel x86 CPUs.
Thank you very much for watching our video. Do share, like, subscribe, and comment.